Okay, uh, we're going to be doing some Atmel 4809 soldering. This is a QFP 44, I believe. Uh, so this should be what's going to be used in the next series of Arduinos. What's nice about it is that it has a little programmable logic on it, much like an FPGA or CLPD or anything like that. So let's just go ahead and get this thing started. I still don't have the camera situation all sorted out, but my little stand should kind of work. Let's get everything in focus. And we are going to be soldering on that guy. Of course, I'd go and just ruin the shot like that. There we go. So one of the things that we're going to do is that there is a itty bitty tiny dot on here, up in the upper left hand corner. This tells us where pin 1 is. So much like how we had on our dips, let me grab a dip real quick. Here's just a regular old dip. You can see a little circle there. That tells us where our pin 1 is as well. I think I've soldered SMDs on stream before, but just in case I haven't, you don't need anything fancy to really do it. What tip am I using? I am using a very fine point tip, but I soldered... I soldered this SAMD right here with using a blunt tip. So your tip size doesn't matter. What does matter is your solder size. So if you have a more finer solder, then that's going to be better. We have our temperature. I'm going to turn that down a little bit to 350 degrees Celsius. And let's just dive right in. Let's get our tip tinned and go from there. It looks like there's some junk on it. Yeah, let's get this guy. There's some... Well, it's mostly off now. I had some... You can see that there's still some junk on the in there, so we want to make sure that we have a nice clean tip. That's going to make it a lot easier to solder. Now that we've got that all done, I do have a new thing that I'm using for to collect my or to clean my tip with. This right here is a jar from the Yoplait Wii. It's quote-unquote a French style of yogurt. It's a nice glass jar. Just got my little not Brillo pad in there. So that should make things a whole lot easier. And let's see if we can, let's see if we can get that angle looking decent. No, we're just going to be like that. Okay, well, I can deal with that. I'm just going to take this and turn it around. We are again using lead-based solder. This is ChipQuick, what's its model number? SMD2SW, 0.020, 8 ounces. This is a 6040, no clean, water washable flux, 2.2% flux core, and 0.5 millimeter in diameter. Unfortunately, I don't have my swing light, but that's okay. We should still be able to get this guy done. Now this QFP board that I have here and using, this I just got off of eBay. I think I wound up purchasing either 50 or 100. I think for like 10 bucks. It's worth it, especially if you're going to be doing some SMD work and you don't have for 44 pins and greater. Now, just like last time, we are going to apply heat to one of our pads. Apply a little, yep. Apply heat to our pads. Apply a little solder. With our tip still on there, we are going to put that bad boy in place. Now what we're going to do is we're just going to look to see that it lines up all the way. We can see that it does not line up on this side. It's a little crooked on here. So let's see if we can politely coerce it to do what we need it to do. Apply some heat here. And again, some solder. Now I'm not too concerned about solder bridges at this point because we're just getting started. Yeah, I've got those pins bridged. But that's okay, because what we're going to do is we're going to turn around and we're going to clean this up. We're going to use some solder wick and we'll just be good to go. So we have all these, so if you're ever afraid to do SMD work, because you're afraid that you're just going to bridge stuff and everything's going to go horrible, don't be. We have the technology. We can clean it up. We can use a little capillary action, get that junk wick out of the way, or get that junk solder out of the way. Everything's just going to be fine. Now you can see that I've bridged this entire line right here. Let's get our wick out. It should be in here somewhere. That's a cell phone. Oh, there's something oily. That doesn't seem good. What kind of oil is it? I have no idea what kind of oil that. Oh, and it's sprayed all over here. Well, that's not good. Apparently I had something spray oil all over my little drawer thing that I used to keep. Oh, I bet I know what it is. Yep, it's not oil. Flux decided to leak. We still have a good chunk of it left, but that's going to be a pain in the butt to clean up. That's okay. We'll do that. There we go, and here's the wick. I need to wash my hands since now they're covered in flux. Okay, and back to where we were. I'll be using a different flux this time than before. And we are going to be using Super Wick number 462 fine braid. Looks like this. I think I got this for a few bucks over at Micro Center. It is really good at absorbing solder. It's some of the best braid that I've ever used, period. So If you find some maybe on Amazon or if you go out to a Micro Center, I would definitely recommend getting some. And now we're just going to place our braid, place our iron, and a little bit of solder to get that capillary action going. Let's lift up, and you can see that already it's a lot cleaner. We still have some issues, but just go again and get what's left. This is a time where it would be really useful to use a blunt tip, because this way you don't have to worry about this fine tip and having to drag it and potentially going through and ripping stuff up, and you don't want that. So I know people always think that a fine tip is the best, but that is not true. It's more about the quality of iron, quality of solder, skill, and let's see how that looks. It looks like I've still got two bridged. I also haven't unpacked my solder sucker yet, so you're not going to see that this episode. And I accidentally soldered my wick. That's okay, we'll do that, we'll fix that. Just apply some more solder to help get that bad boy released. Let's take a look at how that looks. That probably didn't help anything. Yeah, now we got some more that are bridged. I also think that I only have this skinny solder on me, so that means I'm going to always have to use this when braiding, when desoldering. Personally, I like a thicker solder when using solder wick, just because you get more bang for your buck. Yeah, that looks good. On to the next side. I wonder if I am going to be able to solder a pin at a time. I'm very doubtful, but yeah, already bridged. Okay, it was a worthy attempt. Yep. So what I'm doing is I'm just raking across, as you can see. And we're going to rely on the capillary action of the solder wick to pull everything up. So here we've got another nice long bead. Place the iron on. We'll watch it just suck all that up. I don't know if it's going to if it's showing up on stream how well it's sucking it all up, but I assure you it is. And I just bridged all of this stuff down here. Genius. Let me try and come back into shot. Ow. Okay, that looks good. Let's take a look at it. And we're going to come by and test this once everything's done. There's some bridges down here at the bottom. Or I guess it would be there are some bridges. Looks good. On to the next side. Okay, what's going on? Sorry you didn't get to see that, but it wasn't flowing right, so let's just brush off the old tip. Retin. Yeah, you can see that there's some junk on here. Might have to change the tip. Okay, back to where we were. Place it, place the wick, heat it. Watch it all get absorbed. Ooh, there's still a good amount on there. Lift off the wick. Inspect. We have 3 bridges. And these last 3 are bridged at different points and then somewhere here in the middle. Figure out where that guy is in the middle. Nope, that didn't get it. Let's see if we can just clean it with the tip. That definitely got that guy. Does not gain that on that pin. Let's see if I got the other one on the board. Yeah, I got the other one on the board, so now I just have that one on these pins up here. There we go. Let's just bring it up for inspection. I think these guys might be bridged over towards the front. One way to find out. We'll just grab the old multimeter, put it in continuity mode, and if we hear a beep, then we know I messed up. Okay, let's do... Let's figure out what pins these are. So here's one bridge, two bridges. Okay, so these do wind up being bridged. So 64, no, 54, 56, 65. So here's our bridge. Okay. Time to clean it up then. Let's see if it's on the board or on the chip. Yeah, it's on the chip. Get that guy back out in the frame. Looks good. Let's give it a good old look under the loop. Looks pretty good there. That just leaves one corner left. Then we just need to debug. Or I guess check, since we're not dealing any sort of software. Okay, got that all nice and bridged out. Need to get a pair of wire clippers. This is getting a little long for me. Let's bring it up. And yeah, you should be able to see the flow. Oh, lovely, I bent a pen. Another problem with using very fine tips. I'm probably not going to be able to fix this on camera, so... yeah. So what I'm doing is I'm taking this iron over, and I'm just slowly trying to walk this pin back. I hope I don't have to bust out the chip quick. Let's take a razor blade and try and work on this. Sorry for the very boring screen, that's why I'm trying to talk more while I'm working on this part. Just got a little hobby blade here. Give this a good look. Looks like things are in place. Just have a little cleanup to do. There we go. Still a little messy there. I might have to get the chip quick. Only reason why I would get out the chip quick is just because that's going to be hella easier. Unlike with regular solder, this is going to chip quick will let it stay melted long enough. I say that knowing that I'm using Chip Quick brand solder. When I say Chip Quick and when other people say that, they're talking about something kind of like this. This was just a brand that I found on eBay, but it comes in little strips like this. The idea is that you apply it onto your QFP or some other SMD type device, and you wind up. And what happens is that it stays liquid longer. So this winds up being helpful if you want to lift up a piece, if you want to lift up a component. It almost looks like that it's the trace that I broke the trace. Now if I broke the trace, then that means I do have to use the chip quick and just go get a new board. So let's bring out our multimeter and take a look here. Let's see here. This coordinates with pin 90. That's first. Okay. Yeah. Okay, so we do have a bridge on 90 and 91. Okay. Let's get a good look at this guy and see if we can fix it. Yeah, the pad, the track has definitely lifted off. I can try and show it, but I don't know how well this is going to work. So you can kind of see at, counting on this side, 1, 2, 3, that it kind of looks like it's crooked. Let's see if I can fix that using the X-Acto blade knife. So what I'm doing with the X-Acto blade knife is I'm coming in between the two pins, and I'm trying to see that if I can either move it or in some way alter that. I have no problem with cutting a trace. And you will see examples on professionally spun boards where a mistake was made in development, so you'll see a scratch through one of the PCB traces and a bodge wire to fix the error. Obviously that's not the ideal situation, but sometimes when you're that deep it costs too much to respin a board, or if it's already out ready to be assembled and you're just doing final quality assurance. And let's test it. Good. I seem to have gotten that. Okay. That took a long time. Now let's go around each individual pin and see if everything is good or not. So what I'm doing is I am just going across here, This is a 44, so what I'm doing is I'm just going across each individual pin. So this is 28. 28 plus 4 is, sorry, 28 plus 12 is 30, 40. And I'm just going through, testing all these guys. Here you can see that we have a bridge. It looks like it's a bridge on there, on the tracks, right around here. So let's get that guy cleaned up. I don't know if I'm going to be able to do it while being in shot. Probably not, but we'll give it a shot. Yeah, you can definitely see. All I did was I just took the iron, just pressed it down, went up and down, and let the solder flow itself to where it needed to go. Now we're just going to go back and test these guys. Cool beans. Let's come over here. 70. What is 76 minus 12? That is 64. Looks like we got a bridge here. On 65 and 56 and 57, so no, what is that? Yeah. Either way, let's take a look at it. I don't see anything on the board right now, so hopefully that's where it is. No, there's an itty bitty solder bridge here. I don't think I'm going to need the wick, so I'm just going to try and clean this up real quick. So all I did here was just press some heat to the individual pads. Let's give this a go again. Go away. And that took care of that. Now we've got our top here, and we have, what's 100 minus 12? That is 88. Sorry, I keep going out of shot. Cool. Now that we've got that, we're just going to come across here, test each individual, make sure that we have a connection. Okay, pin 91 does not seem to be good. Oh, okay. I see the problem. Just a little off kilter. So for this guy, I'm just going to try and resolder that one pin. So there we go. And I bridged in the process, so let's get that cleaned up. And everything looks clean. Let's give it another go. Actually, let's walk through this again and make sure I didn't bridge anything. Cool. Cool. I I'm willing to bet that we have. Whoa, hold on, hold on, hold on. Just saw something. Okay, I think that this is good enough. I'm going to put some headers on it. Um, Normally, people like to put them on the bottom down here, but I think what I'm going to do is I'm going to put them on top. I think that in this case it's going to be a little easier to see what's going on our chip, especially when you're programming it. Oh, circuit pins. Now let's get a breadboard out. Oh god. This flux is just everywhere. Might as well just take everything outside and hose it down. Okay, 44, so that's 11. Each side is going to have 11 pins on it, so let's count out 11. I need something to cut them with. Now we're going to have 11 per side, but since it's split up 1, 2, 3, 4, 5, 6, 7, 8, 9. Since it's split up on each side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll need to do that, so what is that? That is 6 and 5. So 1, 2. So 1, 2, 3, 4, 5, 6. And there's 1, 2, 3, 4, 5. There's 2. And this is 5. Okay, so that's part of another side. Let's grab another one of these. Count off 6. 1, 2, 3, 4, 5. Two, 5, 6. 2, 3, 4, 5 with a 2 left over. I'm just going to cut off 6 there and donate this guy to our jar. 2, 3, 4, 5. Let's clean everything out. We got 5, 6, 5, 6, 5, 6, 6. Okay, I could have swore that I clipped off a 5. Weird. Yeah, 5. Okay, I'm losing it. Of course, you guys who are watching live or watching on repeat, you'll be able to know, and then we can all have a good laugh. 1, 2, 3, 4, 5. Okay. So because I want the pins facing up this way, I'm going to put them in. Crap. Sorry, that's just me getting an email. So we're going to place them like this, so that we are right side up here. Take it, flip that bad boy on over. Press it in, make sure that all of our pins line up. And now let's solder. Now one of the things I'm going to be doing here is I'm definitely going to be keeping constant pressure because this is not on a solid surface and it does not cover the entire board. And since I'm an OCD freak like that, I want to try and keep this as nice and even looking as possible. Yeah, I'm definitely going to be switching out to a different tip. There we go. Just going to wiggle that guy out. '91, '92, '93. Something isn't adding up here. One, 2, 3, 4, 5, 27, 28, 29, 30, 30, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay. I cannot do math. Get that in, get that nice and lined up. Maybe. Hold on. Technical difficulties. So because of the way that this is laid out, I can't just, keep on going around and around in a circle because these pins will run into this board. So what I'm going to do is I'm going to mirror it. So we're going to take pin 27 and we're going to fill it out by flipping it around. So here's 27, 28, 29, 30, blah, 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 blah. I'm probably going to wind up doing that for all the others, just to make sure that I don't run into any weird little things. Yeah, there's definitely a good amount of junk on this tip. Just need to throw it away. Luckily, tips for this station here are not that expensive. And it is definitely worthwhile to keep some extras ready on hand. Because they go bad. It's not the end of the world. Although this soldering job certainly is. This is horribly ugly. Like, I'm almost ashamed of how bad this is. Weird misshapen blobs. Oof. Messy, messy, messy. On to the next corner. Now on this side I do not need to mirror, so that's nice. And I probably buggered things up anyway, so... I'll definitely have to test this out before doing anything. Well, I'm gonna have to test it out no matter what. Again, for those who know why I'm doing this and you're following me from Snapchat, you definitely know why I need to test this. crumbling. Yeah, I'm still on screen. I suppose for this kind of, for this thing, I could have just used, some solder paste and done it that way, but we didn't. Now again, on this side, you'll see that if I try to do it this way, I can't stick stuff in if I try to put it in the normal way, so we are going to mirror. Hopefully. We are having trouble mirroring. So we're just going to lay it down on my work surface and go from there. Sorry, a little thirsty. Get myself back in frame. And we just have 2 more pins, and we are done with this stream and done with this chip. There we go. I'll probably give it a good test real soon and just do a little hello world, and should be good to go. Thanks for watching.